Because you know I'm all about that bass, about that bass. No, you ain't even gotta tell me no trouble. I'm all about that bass, about that bass. Don't tell me, you ain't even gotta tell me no. Because you know I'm all about that, about that bass, about that bass, about that bass. So you can do what you wanna do. You already know. You can do what you wanna do. So fly like to Tokyo. It was all inside you all the time. Remember my name. Well, now that you know. So the cups got put on my shoulder to see. Was in my front. Because you know I'm all about that bass, about that bass. No, you ain't gotta tell me no trouble. I'm all about that bass, about that bass. You ain't gotta tell me it's gonna be alright. I know you want it, that bass, that bass. No, you ain't gotta tell me no trouble. I'm all about that bass, about that bass. You ain't gotta tell me that's what you want to do. Don't speak the language. Don't need explaining. All that in the morning now. It's gonna be alright. Keep growing, baby. That's what you want to do. Amen. Amen.
Okay. You've never seen that before, really? Just like an old person thing. All right. So how does that relate to piecewise functions? What is that? What is that? Yeah, Robbie.
They're mixing songs together.
Yeah, they're mixing songs together to create.
They're piecing stuff together
One song.
to create one big answer.
One big answer, right?
One
so,
big song.
so that song, yes,
Yeah, Shannon.
Shannon, I do.
She has to say Mr. Wensley.
Okay. Shannon, Mr. Hudson. Okay, yeah, so exactly. So it's pieces of song, and when they put it together, it appears to just become one new, complete song, right? They just kind of go one into the other. Does that make sense? And that one's not perfect. Other years were a little bit better. In theory, there's only one song playing at a time, right? Or it's only showing one music video at a time. It overlapped a little bit the further it went in the song. So, but in reality, you could say like from 0 to the first 10 seconds, it's, I don't know, Taylor Swift. And then from 10 seconds to 20 seconds, it's... Sure, yeah, okay. So there's intervals, right? So different parts of that song are different pieces. Do you see how that's kind of like what we're doing when we make a piecewise function? We're taking different functions and piecing it together to make a new one. Okay, so you don't really have a spot for this in your notes packets. So you find this page. It has the step-by-step, so we're going to skip a few pages for a second just because there's some blank space here. Let's talk about what is a piecewise function. So write that question underneath the step-by-step, which is going to give us the procedure on how to graph them.
This is our review for Algebra 1 packet.
Nope. Piecewise 2.7 packet. There's 2.7, 2.8 from Friday. So you said that song was one song that was made up of pieces of song. So a piecewise function is one function. And if you don't have your packet, get a piece of paper, find your packet, bring it tomorrow. I'm on this page where it says sketch the function. It has 1, 2, 3 that are graphed. So it's a few pages past where we stopped. One function made up of pieces of many others.
Can these functions overlap?
If they overlapped, they would no longer be functions because they wouldn't pass the vertical line test. You'd hit them both. Oh, that's what Mr. Green said too. You'd hit them both at the same time.
And then what if the function has like plus like one that goes over there, and like the one's like minus one that goes over?
Okay, so you'll see in a second. One has to be just less than, and the other one would, or greater than, or whatever. And the other one would be greater than or equal to. So it's only, so say it's splitting at 1, it would only be true for one of them, or would it equal?
Like it has like some that like it adds like more than like the other one. Couldn't it like if the first one adds 3,
Okay.
and then like at 1 or like more?
So sometimes it'll be the same thing, you mean?
Yeah.
Either function will give you the same thing?
Yeah.
Yeah, sometimes that happens. It'll just look
So
like a
would that
V
make
or
it
something.
non-function?
No, it'll be a function. It has to be the exact same point if they're gonna actually hit. You'll see. You'll see, Robbie. Give me time, patience. I know, this is like how my weekend is. I'm like, man, I just want to graph piecewise functions. I have to wait 3 days. I mean, it was a lot for me to wait it out. Especially to play that song.
You can listen to it by yourself.
Did I?
No, you couldn't listen to it by yourself.
I could, and I could try to explain to my husband how it relates to piecewise functions, but he's not really into that. All right, so let's see, broken down into intervals, right? So we talked about like from this time to that time in the music video, maybe it's one song and then it changes songs and it changes songs. So our function is going to be broken down, and we can call it intervals. And it's based on the x-axis, right? So since we've started looking at these, it's saying when x is greater than this or when x is less than that. And as we talked about in the video, especially if we want it to still be a function, there can only be one function, or I'll put one song, okay, if we're thinking about the video. There's only one song playing at a time.
That wasn't true though.
That one wasn't. I think, so he does this every year, you know,
Can
for
we do
little
last year's
outside research. No, not currently, but maybe during Flex Block or something. And when we first started doing it, I believe that was true. This year it wasn't true. But it is true if we're talking about a function.
You do this every year with all the kids?
That is something that came to me recently, so I've never played that song before. I was so excited to do it. That and my favorite now, it was killing me all weekend. I put that on my Twitter if you were following me.
Did you
I was super excited for my favorite now. Yeah, it's my favorite warm-up. I live for this. All right. So, once you get that down, flip back. Let's just talk about kind of restricting our function, okay, based on the domain. So when I'm talking about domain, I'm talking about x, or my input value. Okay, so we have these graphs, and you can see that the actual line is kind of faded out. That's because we're going to add to that line. We're going to draw in only the part that we want, only the piece that we want. So, it says, for each of the following graphs, darken the graph to show the part that would be, I'll cut some of it off, be kept after the domain restriction. Make sure I can see the difference between open and closed circles. So we got to talk about that, open and closed circles. You've experienced that in Algebra 1, but let's talk about it again. So on the top here, if it's less than or greater than, that will be an open circle. And you'll get clarity on this in a second. Open circle, like that. If it's less than or equal to, greater than or equal to, we would have a closed circle. You do this when you're graphing inequalities on a number line. It's the same thing. Open circle, closed circle. So we're going to use colored pencils for a little bit. You wouldn't actually shade a piecewise function graph. Okay, we're going to use it just to kind of visually see where our domain is kind of breaking apart, where our different pieces will be. So, first one says x is greater than 3. So what does that mean? Here's where x is 3. Do you agree with me there? So, if my line, which is already drawn in here, if that was one of my pieces, I would only draw my line where x is greater than 3. Do you agree that that area I shaded, x is greater than 3 in that area? Right? Because it goes x is 3, x is 4, x is 5, x gets greater than as I go to the right.
Yeah.
Okay, these are x's less than 3, so I wouldn't include those values, right? So take a second, you all, does anyone not have colored pencils? Because my first class is smaller. I don't have a ton left. You have some? No? Yes? No? You work the best. Do anyone else? Selection.
Wait, this shorter?
Anyone else? Yeah.
Open. What does it mean by open?
Give me 1 moment and let's see if you still have the same question. You should write it on your notes though, because I see it's right there.
Yeah, I was on your Twitter.
Oh,
I give you a favorite.
yeah, on my favorite now.
Yeah, when I saw the spaghetti thing.
I mean, how could you not love that?
I didn't watch it.
Victoria, did you watch that? Did you finish watching that movie today?
Yeah, I did.
Isn't that awful?
All right, so what does open circle, closed circle mean? So is this, based on this inequality and based on what I told you, open or closed circle? Open. So that means where my piecewise function, where that part of my function starts, I will put an open circle, and then I will draw on the line from there. So these lines are already given to me. Obviously, in a second, we'll actually graph our functions as well. Okay. So the open and closed circle is essentially going to be whatever our starting point is for that piece. If our restriction on our domain, if the information is telling me it's just greater than or less than, I will place an open circle where my piece starts. If it's greater than or equal to or less than or equal to, I would put a closed circle there and then draw on my line. Filled in circle, like that. Trey.
Would we put an arrow on the end where it ends?
Definitely. So some of our pieces, they'll continue on, right, and have an arrow. Some will go from like point A to point B, and then you would just have 2 points. You'll see in a little bit when we start graphing them. This is just kind of like a building block. This isn't actually kind of how it's going to look for us in a second. This is just talking about restricting our x values. So then, that's weird, they both say number 1. I have this new line. This time it says x is greater than or equal to -1. So I'm only going to draw in this line for values of x that are equal to -1 or greater than. So first of all, here's where x is -1, right? So if I were to shade where I want to draw my line, would I shade to the right or to the left? To the right. That's where x is greater than -1. Does that make sense? Okay, and again, you will eventually not shade this area. It's just kind of to get you used to the pieces. This time, would you put an open or closed circle for that line? Closed, because now it's greater than or equal to, which means I want to include the point where x is negative 1, because you would use this function if it was equal to negative 1. And then here are my points, whoops, going in that direction. So it's the only piece of that line you would draw in when we get to graphing them in a second. How are you doing?
I don't understand about the open and close circle.
Okay. Wait till we do like a real graph of the piecewise function, and then if you still have a question, then ask me, okay? Okay, if you flip this over, you'll see two, well, no, I'll do this with you because there are two restrictions. Okay, so our next one, now it's giving us kind of two values here. So the way you read this, we're going to show our line only from values of x that are greater than, so you read it from your variable, x is greater than 3 and less than or equal to 10. So greater than 3, less than or equal to 10. So if I were to shade that region, well, here's where x is 3, 4, 5, 6, 7, 8, 10. Here's where x is 10. I'm only going to graph my line right here. This is the only piece of that function that's included. So go ahead and just shade the area we want to include lightly. So that's from 3 to 10. Now this is where the open and closed circles comes into play. At 3, will my function have an open or closed circle? Open. Why would it have an open circle? Dylan. What makes it open? Other Dylan who's struggling here. What makes it open? So I'm looking at this inequality. Okay?
Wait, if it's
Just less than or just greater than, I will write an open circle.
so that's it, that's all that
Yeah,
matters?
and if it's less than or equal to or greater than or equal to, I'll have a closed circle. So at 10, I have a closed circle.
Wait, so if it's open circle, if it's what?
Just less than or just greater than.
Less than or greater than?
And if it's less than or equal to or greater than or equal to, it has a line underneath your inequality, it's a closed circle.
I get that.
Yes.
The reason why it's open is because it's not actually on
Mhm.
3. It's
Mhm.
just right after 3. And the reason why it's closed is because it's actually on
It's
10.
including that value, exactly, yeah. So the reason it's open is because it's just for values of x that are greater than 3. So we don't want to include 3 in our function. The reason it's closed here is because I want to include when x is 10, because it's less than or equal to. Exactly.
Helpful.
Closer there. Good there. So next one, really similar. So I'm looking from -2 to 0. So let's kind of just shade the region we'll include. Doesn't include my line there. So here's -2 to 0. Shade that area. That's where I want to include my line, which doesn't go there. So let's see. Looks like I have a slope of -2. So you can just kind of continue. Your line that's not really filled in, if you start here, has a slope of -2. So you could draw in the other points. So there's my piece, but I have to include circles. So at -2, open or closed circle? Open. And at 0, open or closed circle? Closed. So this line I just kind of extended because it didn't go into my region.
What do open and close circles help?
What do they help? So if you had just the graph, which you will in a few days, and no lines, and you needed to write the actual function, this tells me it's not equal to, when I write my restriction, it's just greater than 2, but it's less than or equal to 0. It's the same thing that Robbie was talking about. If it's closed, that means I include this point when I evaluate it. If it's open, that means I don't use this function for -2.
Well, if you don't have a line, how do you know where to dot it?
You would have the line. Saying if it didn't give you the equation, it didn't give you, we don't have any equations here, like the f of x part. So that's going to be part of this unit. It's going to give you a graph, and you're going to have to write the function. So having the open and closed circles tells you how to write your function.
How would you use open or close then?
What do you mean?
If they didn't give you the equation, how would you
You'll
use it?
have the graph. So you'll say, okay, so greater than -2, but not equal to. less than or equal to 0, then you'd be able to write this piece based on the open and closed circle.
Oh, would they give you the circles?
Yeah.
then? Okay.
Yeah. Okay. Let's do one more where we're just kind of filling in our line, and then we'll talk about how we actually do the whole process. Okay, so this one's just x is, let's see, less than 8. So let's shade where we would include that. So 8, 3, 6, here's 8. X is 8. So if I want to include values where x is less than 8, am I going to shade to the left or to the right of 8? Left, yeah, less than to the left. I say that when I teach just like straight up inequalities. Okay, my values are going to be less than to the left. Here's 8. Here's values less than 8. The x-axis, if you've never thought of it this way before, is really just a number line, right? So if here's 8 on the number line, here's my values less than, here's my values greater than. And what type of circle would I have? Open, based on the inequality. Boom. There's the piece of that line that I would include when I graph. We're not doing number 5 for now. We're going to keep that for probably Thursday, depending on how you do tomorrow without me. Alright, so let's get a procedure down. I like writing things out in procedure. Step by step, how do I accomplish this task, right? So we want to graph these functions. Okay, so the first thing we're going to do for right now is we're going to shade any domain restrictions. So eventually we'll get rid of that step because in a piecewise function there's not actually any coloring or shading like there would be like on a system of inequalities or something. But for right now, let's shade any domain restriction. Okay, X is my domain. So I'm going to shade kind of where will the pieces be, right? So my first one is when X is less than 1. So let's shade that. So here's 1. This graph, 1/2 X plus 3/2, I will draw in for values of x that are less than 1. So where will that first graph be? Am I going to shade to the left or to the right? Left. To the left. And as I do this, to help me for when I get to the piece where I'm actually going to graph that line, I'm just going to put the same color that I shaded up there. So I know this graph is only being graphed right here, where it's red. And then take another color and shade the other part. Okay, negative x plus 3, we're going to have when x is greater than or equal to 1. So that's where my pieces will kind of break. That makes sense. One piece is over here, the other piece is over there. Okay, so step 2 is just looking at my first function. I'll write in red actually, so keep it. So I have 1/2 x plus 3/2. That's my first function piece. I'm going to make a table. And you're like, oh my gosh, there's fractions, so I want to cry. Can you all grab a calculator, please, so we can refresh our memory on how we can get a very quick table from our calculator. So if you don't have a calculator, come grab it now. Your numbers are right here. Oh, wait. Oh, wow.
This way, and I could go.
Lucky for you, this lesson will be on the website later. You can spend your afternoon rewatching. Okay. So let's talk about about how, because you could do a table, you could do it out by hand, but why? We have this technology. It's going to speed up the process. We don't want all of these to take you 20 minutes. So in your calculator, turn it on. Make sure your calculator is working, because that's your calculator for the semester. Okay. So in y equals, so if you go into y equals, wow, look at that. Clear out anything that's in there.
Wait, where did you go?
Y equals, so y equals at the top here, y equals right there. Y equals, clear out anything that's in there. They should all be clear. Okay? What you can do in here is you can just go ahead and type in your function that you want to make a table for. So I have 1/2 x. Do you all know where x is on your calculator? If you look at alpha directly next to that, it says xt theta n. If you press that, it's going to give you x, unless you're in some weird mode. Okay? So you type in 1/2 x plus 3/2. Now, there's one point I want you to always have in your table. That point is whatever value is right here. So I want basically that starting point where your function's going to start. So I want to include 1. Yes.
Oh, how did you get X on there?
X. So right next to alpha has xt theta n.
Oh,
Okay. So I typed in my function. I just need a couple points. I really only need 2 points to graph a line. But if I want to include 1, because that's where my function will start at, in that shaded region, then my graph is only going to be where this red area is, which is values less than 1. So give me like 2 other values I could look in my table and get. What's a value less than 1? 0, and how about -1? Now you're going to get fractions here, right? Because you have fractions, and that's okay. Fractions exist. We have to deal with that. Okay? So everyone here, you've typed this in. If you just hit second graph, woo, look at that table. Hold on, I gotta change my table settings. Anyone else have a table that starts at a really high number? Okay. If you hit second button and your graph button, it brings you to a table of values. Okay? Brings you to a table of values. Anyone not get there? Because I want to make sure you can get there. It speeds up your work. When you have 5 of these on a test, you don't want to be doing it all out by hand. Okay? Anyone not get there? So this is giving me a table. All I'm going to do is copy it down. When x is 1, what is y? 2. When x is 0, what is y? 1.5. When x is -1, what is y? 1. So let's draw in our graph. 1, 2. Now I always want you to get that initial point, okay? And we'll talk about whether we want an open or closed circle there in a second. 0, 1 and a half. -1, 1. That's what my points look like plotted on my graph. See how I'm only including points that are within that shaded region, because that's the only piece of the function I'm including. Lost my ruler. What type of circle should be at that, what I call initial point or starting point of this piece? Open or closed circle right here? Open. How did you know that?
It's just less than.
Yeah, right here tells me that when I draw on this line, it will start with an open circle. Okay, x is less than 1. That means I can't include 1 because I wouldn't use that function if x equals 1. Okay, so I have an open circle, and here's my piece. I have an arrow here because there is no restriction over on this side of my line, right? It was just going to continue on. Any value of x that's less than 1, I'll use this function. So you want to have an arrow. We're not there yet.
What about the others? Is that
Right here?
Yeah.
No, this is just a point. Because
Array?
once I cross into this green area, yes, it is array. Once I cross into this green area, this function is no longer what I would use, right? I'd use my other piece. Okay? I know this is complex. So, there's my first piece. Now, let's look at my second piece. -1x plus 3. So I want to add to this. Make a table, and then you always ask yourself, open or close circle, okay, when you graph. So that's the first piece. Now I'm going to do the same thing for my second piece. Here's my second piece. Make a table. You can use your calculator. This one doesn't have fractions. It might not be as intimidating. Now, when I make a table, I want to start at where my function's going to start on my graph. Where's my function going to start? 1, yeah. And then it's going to be values that are greater than 1. So give me a value greater than 1. 2 and 3, sure. So what you can do if you want to use your calculator, go back to y equals. Clear out your first piece, write in your second piece. Negative 1x plus 3. There you go, that's better. Okay, negative 1x plus 3. Second graph brings you to the table. Here are my values, 1, 2, and 3. When x is 1, y is
2.
When x is 2, y is? When x is 3, y is 0. So what happens here? 1, 2 is my first point. 1, 2. What's happening? They overlap. So it's just going to look like it's going to be a V. Yeah. So when that happens, here I would have a filled in circle, right? Because my function, sorry, I gotta scroll up. My function is greater than or equal to 1, meaning I want to include that point where x is 1. So what happens when that overlaps is it ends up looking just like a closed circle, right? Because you have an open circle and you overlap a closed circle on top of that, it looks like a closed circle. That's okay. So I have 1, 2, 2, 1, and 3, 0. Graph my line. There is my piecewise function. Okay? For values of x less than 1, I would use this piece, that line. For values of x greater than 1, I would use this piece.
So how does open circle and closed circle help here?
There, because they overlap, but you would still include them. They overlap, so it just makes it so you can't see the open circle. Are you okay if I flip pages? Okay, let's look at another one. Okay, so this next function has 3 pieces. First thing I want you to do, let's decide a color for each piece. Okay? So my first piece I'm going to do in red. I use pens. My next piece I'll do in green. You don't have to do the same colors, but if it will help limit confusion, then go for it. My last piece I'm going to do in blue. So I've set this up nicely for you so that you have workspace for each function to figure out kind of what you're doing. So let's kind of just rewrite our functions first before we shade. So our first function, and f of x and y, really interchangeable. Okay, f of x and y, so instead of writing f of x equals x minus 2, I'm just going to write y equals x minus 2. There's my first function that I'm going to do in red. Y equals x minus 2. I'm going to put that in this first box. This gives me some workspace. My next function, y equals x plus 1. That last function's a little bit funny. What would that look like if I rewrote it down below? Y equals 4. And we talked about those on Friday, maybe, or Thursday of last week, and we talked about hoi and va. So y equals 4 is a hoi when we get there. It's a horizontal line where y is that value. That one's actually really easy. We won't need a table because it's just a straight horizontal line right there. So let's shade to show where we're going to include each line. We will draw on the line y equals x subtract 2 between negative 4 and negative 1. See this? This is giving me restrictions on each side. So between negative 4 and negative 1. So here's my x-axis. There's -1. Here's -4. That function is only true between -4 and -1, so I will only shade that little spot. Notice I'm shading pretty lightly, but it's just to kind of help guide you so you know, like, oops, I went over where I should have. Okay, I'm only going to include that line between -1 and -4. And then my next piece of my function, I will include between -1 and 3. So here's -1, here's 3. That piece is only valid between -1 and 3. If you had an x value outside of these, then you wouldn't be able to evaluate it with this function. No solution. Just as a FYI. Okay, so that's where I'll draw on that second line. I'll only include it from -1 to 3. And my last line is for any value of x that is, oh, that should say greater than 3. Fix that. Any value of x that's greater than 3. So here's 3, to the right would be greater than. Shade, 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 shade. So that's how my pieces will be divided, right? On one piece, another piece, and a third piece. Okay. So my first function, I'm also going to write my restriction here underneath. Now I want to make a table. Which values should I include on my table? Let's include -4, right? And what else? Sure, let's just do -4. You only need 2 points to draw a line, so let's just do the 2 kind of points that we're going to have an open and closed circle at. So if you don't want to use your calculator, by the way, all you really do to evaluate these is if x is -4, I'm plugging -4 in here. And what would you get out for y? This one's pretty quick. If I plug in -4 for x, I would get y equals -6. If I were to plug in -1 for x, I would get y is -3. And you could have done that in the calculator, by the way, if you don't like to do it out, but that one's pretty fast, okay? Not that much involved there. So, before we draw on our line, let's talk about the open and closed circle business. So, this point will be a x is greater than -4, so it'll be a open circle. X is less than or equal to -1. This point will be a closed. We only need 2 points to draw on a line, so let's put in those points. -4. -6, open circle. -1, -3. Closed circle. Connect your points. And the next one, once you draw a new line, rewrite that kind of restriction on our x values underneath, so we have it there to refer to, yeah?
So how does, I'm not still understanding how the closed circle even does anything there.
Okay, so this is why there's a closed circle there. Remember on Friday when we were evaluating them? So if I asked you to evaluate this piecewise function when x is -1,
Evaluate, what do we do to evaluate?
that's what our warm-up was. So when you're just like, what if it said f of -1? You would look up here and say, which piece would I use for when x is -1? And you would choose this piece because it's when x is less than or equal to negative 1.
So what is the closed circle to do?
So the closed circle means I'm including negative 1 and values less than that up to 4. But
So
the
you're-
open circle is here because if you look at my
So the
restriction, I'm
open
not
circle?
including 4, I'm just including values greater than or negative 4.
So the open circle is like the end value and the closed circle is like the start of the value?
The closed circle implies that I'm including that point in my function. I'm including negative 1 because that function I'm going to use if it's less than or equal to negative 1 or if it equals negative 1. But this point is open because it's just x is greater than negative 4. I wouldn't use it if it equals negative 4. Negative 4 is not included there. It's only values greater than. It's this line right here that's making the difference. If it's equal to that value,
If
I would
equal,
have-
it's open, and
if it's
not,
equal, it's closed because I want to include it. If it doesn't have the line underneath, it'd be open because I wouldn't want to include that point, just values greater than or less than that point. Okay, let's look at the line I have shaded in green. X plus 1. Again, let's make a table. Now, when we have two sides here, it's pretty clear which points you should probably choose. Now, this is obviously going to be different based on each function that you encounter. But if it were me, I would choose x is negative 1 and x is 3. So I get kind of my start and end of that piece. This is probably when you don't need a calculator for. If I plug in negative 1, what am I going to get out? 0. If I plug in 3, what am I going to get out? 4. Okay. Now let's talk about how we're going to graph these points. X is greater than negative 1. Not including negative 1, just greater than. So that is going to be a open circle. X is less than or equal to 3. So including that point as well. So this would be a closed circle. Only need 2 points to graph a line, so let's do it. Negative 1, 0, open circle. Kind of hard to see there. Should be open. And then 3, 4, closed circle. There's my second piece.
Do you have to do arrows?
Nope, not for those two because they have restrictions on both sides. So it's starting one point and it's ending another point. The last one will have an arrow because it just kind of has like one value and then it goes on. Any value greater than 3 will use that function. So this one, again, I told you kind of an error there. Should be x is greater than 3. My fault. Sorry. So x is greater than 3. I don't need a table. Anytime it's just like y equals 4, you should think hoi or horizontal line where y is that value. So this is just a horizontal line where y is 4. Now your notes tomorrow when I'm not here, every single function is just y equals a number function. They're called step functions. So if you have one horizontal line and another horizontal line and it creates what looks like steps. That's why they're called step functions. So I'll record that, but they're all just like, boom, you won't have to make a table. You're just drawing those horizontal lines. So y equals 4. Y equals 4 is right here. I'm drawing that horizontal line in. Notice it overlaps with the point from my function that I have in green. This would technically be an open circle, right? But it's overlapping on top of a closed circle, so it may just appear closed. That's okay. Why do I have an arrow here? Because it just goes on. It doesn't tell me. Like, it just says when x is greater than 3. It doesn't say when x is greater than 3, but when it's less than 10. That's only true. No, it's for x is greater than 3. So it could be x is 1,000,000. That's the function I would use. Okay? It just goes on and on and on. No restriction on the other side.
And it's open?
Open circle, but it's overlapping a closed circle, so it's a little bit messy there.
So it's only closed if it's equals?
It's only closed if it has that line, if it also equals that value. If it has the line underneath the inequality, yeah. Okay.
But it's open anything else?
Open otherwise, yeah. Okay, let's do one more together and then I'm gonna let you work the rest of the class. I'll leave this up here for a second if you're still working.
I have a question on this one.
Mm-hmm.
It says that for the two functions
Mhm.
that x can be equal to 4 in 2 different places.
Does it overlap?
Yeah.
Show it, that's why. It's just probably,
Well, like it's.
oh, it's at two different spots.
Yeah, so they want to be.
It's another error on my part. Change one of them. Doesn't really matter. Change the second one to just be greater than.
Now I made a red circle. Oh, that one. That's good. Okay.
You'll survive. Alright, again, assign 3 colors. I will again do red, green, and blue. Error here. Let's not have it equal to in 2 different places. Erase that underneath. Let's just have it be x is greater than 4 in the last one. Because then if it was 4, like you wouldn't know what your value would be. It will also make it not a function. So we don't want that. Okay. So if you remember, I said vertical line test before, but if you remember, every input can only have 1 output. That's also why I had to correct that, because if you had 1 input 4 and it was true for 2 different things, you'd have 2 outputs. It would make it not a function. So again, sorry, cross it out. Okay.
If you sign, we can make functions that can have more than one output.
It wouldn't be a function. It would be called a relation then. In order for it to be a function, math vocab like fits the definition of a function, every input can only have 1 output. If that was true, if this was like this, it'd be a relationship. It'd be a relation, but it wouldn't be a function because the input of 4 would have 2 different outputs. Did your mind just blow up a little bit?
Like we were making some designs and like we had like we would get more than one thing back.
Mhm. So it's a relationship, but it's not technically a function. Definition of a function is every input only has 1 output. Okay, so first one, y equals, so just rewrite the y in front of it. That'll in particular help you with the ones that are just numbers. So y equals -1/2 x plus 1.5. Ooh, use the wrong color. That'll be true if x is less than -1. The one in green, that's the line y equals 2. That'll be true from -1 to 4. And my last line, y equals x subtract 6 will be true from 4 to 8. Okay? Let's shade where each of those will be. Let's keep doing that for a little while. Make sure we're good here. So x is less than -1 is the first one. So here's -1. Where will that function be? To the left or right of that value? Left, yeah. So that function will start at -1 and be drawn in to the left. Okay, that's my first piece. My second piece, y equals 2, is from -1 to +4. That's to right there. Need that piece in the middle. And the function I'm doing in blue here is from 4 to 8. So anything beyond 8 is undefined. It doesn't tell me what I would get out. Okay, that's where my pieces will be placed when I go ahead and graph. What's the only value I care that you have on this table? I want you to have when x is -1. Okay, that kind of where it's going to start up here. And I only need 2 points to graph an equation, linear equation. So it's true for x is less than, any x's that are less than -1. So it's another x value that's valid there. What's less than -1?
-2.
Great. Okay, and if you want to, you can use your calculator, especially because you have fractions, and I know you guys are all terrified of fractions. -1/2 x plus 1.5. Table. When x is -1, y is 2. When x is -2, y is 2.5. So this point right here, that's where it's going to start, right? So is that going to be an open or closed circle based on my inequality up here? Open. So I will have an open circle at negative 1, 2. Open circle. And then I have another ordered pair at negative 2, 2.5. And on my line. Why do I have an arrow on that one? It's only restricted on one side of my line, right? It's just for values that are less than negative 1. So it's going to go on and on and on and on forever. For x is negative 2 billion, it doesn't matter. If it's less than negative 1, that's the function I'll use.
Why? What is it, open or closed?
Open,
Why?
because the line underneath, it's just for values that are less than negative 1, not equal to.
There's no, if there's no line, there's no equal to?
There's no equal to, right? Next one, no real need for a table. This is a horizontal line where y is 2. Okay, horizontal line where y is 2. Y is 2 right here. I have a horizontal line right there. Let's talk about open and closed circle. At negative 1, is it open or closed? Open. And at 4, is it open or closed?
Closed.
Closed. So let's talk about it. What happens if it asks me to evaluate this function at negative 1? Open there. There is no value, undefined. Okay, if it asks me to do negative 1, that's like a gap in my function. Nothing there. Okay, these are both open circles. Great. Last
How would
piece.
you be able to tell on the since there's like a curve?
How will you be able to tell?
You see how like it's like an open circle, but it's a point, so it looks closed. How are you gonna be able to tell if you're like?
Because you are going to use pencil on your work in a second, and you're going to just make it very obvious. Like a larger point that's open around it. Okay. All right, next one, 4 and 8. Okay, it's going to go from one point to another, so why don't we use 4 and 8 for our values of x? So we get those specific ordered pairs out. Probably don't need the calculator for this. If I plugged in x is 4, what would y equal?
-2,
Negative 2. And if I plugged in 8, y would equal?
2.
2. So starting with the x is greater than 4, open or closed circle here. I changed it, so I took away the line, so it should be open. I was a mistake on the paper. And then at 8, it'll be a closed, less than or equal to. 4, -2, open circle. 8, +2, closed circle. 2 points, there's my line. This part of this unit is difficult. Like, there's no doubt. This is actually, I feel like, one of the most difficult sections of all of Algebra 2 Honors. It's just a lot of steps and a lot to remember and a lot of ways that you can make a mistake. Okay, so you just want to be really careful, and we're going to spend some time with this, but it's a difficult section. Okay? Algebra 2 Honors starts out with a bang with this one. So, if you flip this over, you will see 3 practice problems. That is what I want you to work on for the rest of class. If you don't finish it, then you would do it for homework. Do not move on from there. If you flip that page, that's what the lesson is tomorrow. Okay, so do not go any further than those 3 problems, please. Okay, I will pass back your formatives from Friday. I'm not going to go over homework today, only because I want to give you time to work on these while I'm here. Okay?
Are we in here again today, or are we in the other room?
I moved them to the other room because I didn't like all the, you know,